Okay, welcome to Unit 6, Lesson 1. We're talking Pythagorean Theorem. In Unit 6, we're going to begin with solving for a missing hypotenuse. That'll be our first objective. So you will solve for the hypotenuse in a right triangle when given the lengths of two sides. Our vocabulary comes from here, the hypotenuse. That is the longest side of a right triangle. A right triangle forms a 90-degree angle at one vertex. And not only is the hypotenuse the longest side, but the hypotenuse is always opposite the 90-degree angle or the right angle. And then we're going to be given the lengths of two sides, and we're going to call those other two sides, we're going to call them legs. And the legs, there's two of them. They always form the 90-degree angle at one point where they intersect. And then we will build this Pythagorean theorem as we work through this first example here. Okay, we're going to hopefully look for how reasonable our answer is. If you take a look down here, we have a right triangle. So the first thing you want to do when you find your right triangle is you want to label the vertices A, B, and C. Okay, that's the very first thing you want to do. And the letter C, we're always going to put, that will be the right angle. So you need to find the right angle, label it C. And then I want you to travel across the triangle. And we have a capital C here. We're going to write lowercase c right there. It's hard to see, but okay, because this is the hypotenuse. Okay, and then here, where you see A, I want you to put a single arc. You can use blue ink or red ink, but I want you to travel across the triangle to this side, and we're going to write little a, and that's a leg. And we'll do the same thing here. Two arcs because it's a different angle. You can see that this side is slightly longer than this side. It's about 1.5 centimeters. So that's capital B, travel across, make that little b, and that is called a leg also. So we have two legs and a hypotenuse in a right triangle. It asks you to measure these and observe what happens. So if I take and I measure this using the centimeter side of my ruler, I get side BC as 6.5. Side CA, if I measure this correctly, 9 centimeters. And the longest side here is 11 centimeters. I can see that segment AB, which is the hypotenuse, is always the longest side of the triangle. The hypotenuse is the longest side of the triangle. Additionally, it is also the side opposite the right angle. So it's opposite the right angle. It's also the longest side. And something special that happens here with any right triangle is something called the Pythagorean Theorem, okay? And how the Pythagorean Theorem works is, let's draw a simple the simplest right triangle here. It's 3, let's call it 4, 5. It's the 3, 4, 5 triangle. And something special that happens here is if I was to make a square out of this right here, I'm going to just kind of freehand a square. What is a square? Measurements. The sides are all the same length, so it's 3 by 3. Go ahead and put in the chat. What's the area of this square? It's 3 by 3, or 3 squared. And I see that you have already answered it as 9. Okay, let's look at the square of this from this side. If I build a square, what is the area of this square? It's 4 by 4, or 4 squared. It's 16. Thank you. All right, well, let's build the square on the third. So I need 1, 2, 3, 4. 1, 2, 3, 4. How many is this? Oh, 25, I see. Good job. So I've got 9 and 16, and I got 5 squared and 25. What do you notice about the squares of the first of the legs relative to the square of the hypotenuse? So we're looking at the square of both legs, 9 and 16. How does it relate to the square of the hypotenuse, 25? So the question is, you have not, this square is 9 and this square is 16. That's right. 9 plus 16 equals 25. Well, nothing has changed here. That means that 3 squared plus 4 squared equals 5 squared. And that's where the Pythagorean theorem comes from. So if I, instead of calling this side 3, I call it A, and this side I call B, and this side I call C, then for any right triangle, I have this general formula that says, okay, instead of 3, I'll just call it letter A. So it's A squared plus B squared equals C squared. That's where the Pythagorean theorem comes from. It's thousands of years old. Even before the Pythagoreans discovered it, other cultures had already been using the Pythagorean theorem for long before the Greeks. So let's practice first looking at special right triangles in the relationship of their sides. So these are special because their sides form integers here. If they have integer sides and they're right triangles, they're called Pythagorean triples. And we can build them. We can build it with using a ruler. We'll build it 3, 4, 5 triangle. So I need one side to be 3 and one side to be 4. I'll make the bottom side 4. I went from 10 to 14 there. It needs to be a right triangle, so I need to go, this was 4 units, 4 centimeters. This will be 3 centimeters. And then if I connect this with a diagonal, I get my right angle here and this would be 5. Because it's a triple, we're going to prove it by the converse of the, is this a right triangle with these numbers? Let's check. Does 3 squared plus 4 squared equal 5 squared? We just did that on the previous one. Yes, 9 and 16 equals 25. So check. Basically, if you're given 3 sides, you can plug it into the Pythagorean theorem. If you get it true, then it's a right triangle. We call that the converse of the Pythagorean theorem. But there's other things we should notice in here. The sides 3 and 4 are not the same length. Therefore, we form here some different angles. But before we even do that, we still need to label this thing with A, B, and C. Where does the capital letter C need to go on this triangle? There's 3 vertices. We're going to label them A, B, and C. Where does C need to go? Where does capital letter C need to go on this triangle? That's right. It needs to go here at the right angle, at the 90-degree angle. That's always going to be your capital C, and you'll travel across your triangle and call that side over here, the hypotenuse, little c. That's always the hypotenuse. It's important because that's where you see this, it's equal to the c squared. That's your hypotenuse. The hypotenuse value, the length of the hypotenuse. So remember that these guys are legs. It doesn't matter at this point which one you call A and B. It does matter if you call this guy A, then you got to go diagonal. I mean, you have to go across and call that lowercase a. And if you call this one B, lowercase b. So we'll always start by labeling them. Find C first. And of course, this is a leg value and a leg value. So you have the basics. There are only a finite number of right triangles that you can build. Remember, this angle is bound in a right triangle at 90 degrees. So again, right triangles are 90 degrees. They have one 90-degree angle. So then the other two angles right here, they have to, so if I'm going to BAC, so remember the angle BAC plus, so the measure of BAC, and the measure, that's BAC, I need the other one, ABC, so I'm talking about BAC is here, ABC is here. So if I look at those two angles, these other two have to add up to 90 degrees. So I'm forced, because one angle's already occupied with 90 degrees, the sum of all three has to be 180. So the other two always have to add up to 90 degrees. This is where in high school all your right triangle trigonometry is going to come in. Since you have that fixed angle here, you would have to measure for the other ones. So if I measure this angle, this is 0. If I take this out as far as it goes, I have 10, 20, 30, 40, 50, between 50 and 60. It looks like it's really close to, it's either 54 or 55 degrees. I'm going to say 54 degrees. So if this is 54 degrees, What does this angle have to be? If I was to measure it, what would it be? That's right, 36 degrees. So if I continue to stretch this, if I take this leg, this angle has to stay 90 degrees. If I pull it this way, this angle naturally will have to get bigger. And this angle, if I pull it out this way, will get smaller and smaller and smaller and smaller. The largest this angle can ever get to is 89 degrees if I go all the way out and make that a 1 degree over here. Because this 90-degree angle is fixed. Okay. So we have this is the 3, 4, 5 triangle. The other common triangles you're going to see, we'll discuss. The isosceles right triangle is 45. These angles would be the same, and these sides would be the same. We'll talk about those later. Another important triangle is the 30, 60, 90-degree triangle. So now we're going to make another right triangle with these dimensions 5, 12, and 13. So we need to make sure that we know what is the smallest and the largest sides. 13 is the longest side here. So it has to be your hypotenuse, which makes that a leg and a leg. So I'm going to build the two legs. I'm going to start with them because that's where I form my 90-degree angle. So I don't have enough to go out 12. 12's pretty, well, maybe I do. 10 to 22. I could do a full. So I'm going to start down here. I'm going to make my first leg 12 units. And then I can go up 5 units. And I have formed my 5 and 12. And I have my right angle. What letter should go right here before I finish my triangle? What letter should go at the 90-degree angle? The letter capital C, correct. So now all I have to do is connect my triangle. And I call one of them A and one of them B. That makes, going across here, little c. We're given that it's 13, but you can prove it. A squared plus B squared equals C squared. Let's prove it. Let me mark this angle here with one mark and a double mark. That tells me that these angles are different. And you can now see, as this leg grows, this angle has shrunk. So if this is capital A, I'm going to call this little a, sorry. Lowercase a. Capital B, lowercase b. And I'm testing. A squared is 5 squared. B squared is 12 squared. Does that equal 13 squared? This is the converse of the Pythagorean theorem. 25 plus 144, does that equal 169? 169 equals 169, so yes, this is a right triangle because it fits the Pythagorean theorem. So if I wanted to measure the angles, I only actually have to measure one angle because this angle I already know is 90 degrees. So now I just need to figure out one of these angles. I'm going to choose the longest one to make that the 0. Set my target right on the vertex. Make it flat. Get your target just right. Push down with your hand. 20, so we go from 0. This angle is being formed here. 0, 10, 20, 21, 22, 23. 23 degrees. If this is 23 and 90, what does this angle have to be right here? Now just a quick review. Angle BCA, you need to use 3 letters. That's 90 degrees. Angle BAC, we measured that to be 23 degrees. Now we're going to use math. We need to subtract from 180. And when you do that, thank you, Stephanie, we do ABC equal to 67 degrees. And so, if you were to make a statement about the lengths of the segments, please remember that you need to put a bar on top of the 2 letters that form the segment. So if I'm talking about the length of BC, I use the segment symbol above the 2 letters. And I'd put 5 centimeters. And if I was talking about this segment, I could do CA. That would be in that direction. If I do AC, it's in this direction. I just do CA. It's equal to 12 centimeters, and BA is equal to 13 centimeters. If you need to screen capture, you do that quickly, screen capture. So if we go to our book on 412, again, you'll see the Pythagorean Theorem laid out. Let's add what we do with the vertices. The lowercase letters, again, represent the side lengths. So you need to put the vertices opposite. Capital A. Here's B, capital B. And of course the 90-degree angle, capital C. Should use red ink for your arc, for your angles. So we know that if we could do a squared plus b squared equals c squared. So if we're missing a component, if we have 2 legs, there's 3 unknowns. If we know 2 of them, then we can solve for the missing one. And we'll start with the simple case, missing hypotenuse in the first situation. That's what's here. Missing hypotenuse. So that's what we're going to do here. And I've put a nice step-by-step list together for you to follow. We want to identify the triangle parts, looking for the legs and the hypotenuse. We know how to do that. Capital C here. Call one of them A and B. Then we have our right angle and C. Okay, so we have to go ahead and call 9 would be little a. Remember, we travel across from the vertices, and this would be little b. So here we have 9 squared, because a is 9, plus 12 squared. But we don't know c squared now. So we've identified the triangle parts, leg, hypotenuse. We labeled the vertices. Point C is at the right angle. We substituted the values in for A and B, but we don't know C. So now we have to use a calculator, and we have to do it in the right order. We have to follow order of operations. That tells us look for parentheses. I don't see any parentheses. I'm going to go ahead and cross it off. But I do have exponents. To square something, I have a button on my calculator, or you can use any website. You're going to type in the number, and then you're going to hit this button here, x squared. So I go 9 squared, which gives me 81. I do the same thing for 12 squared. That's going to give me 144. And I can't do anything with c squared at this time. I've evaluated exponents. I look for any multiplying and dividing, which I don't have, which leads me to addition. I can add these together. 81 plus 144 is 225 equals c squared. Now, you might ask yourself, well, do I divide by 2? And the answer is no. This is c times c, or c squared. So the only way you can find out what c squared is to take what we call the square root of c squared. And then you'll take the square root of both sides. Because you do to both sides, this is an operation that you're performing here. So now you're going to take the square root. It's this symbol on your calculator. The square root of c squared is going to be c. And now you got to find the value of 225. So let's push the button. Square root 225 equals, and you get your answer. It's 15. Okay. So another thing you might be asking yourself is, okay, well, what does this actually mean, this c squared? Remember, in the beginning, we talked about it being a square. It would be in this shape. If I was to build a square, this square would be 225. What does that mean? It means it has a dimension here of 15 by 15. Now, if it's some number, let's say it was 224, then you're going to get a number in a decimal that's slightly smaller than 15. It'd be like 14.9. This just happened to be a perfect square, so the dimensions of the sides are exactly 15. We have time to do one more. All right, page 413, we're going to do the same practice here. We're going to identify the legs and do the vertices. So we're doing A and B basically at the same time. This is C, A, and B. Makes this little a, little c, little b. And we plug in for what we know. We know the two legs. We know 18 squared plus 24 squared equals c squared. We'll use our calculator. 18 squared, 324, 24 squared is 576. Equals c squared. We'll add those together to get 900 equals c squared. What do I do at this point? I have to take the square root of both sides. So I'm going to do that. Square root of c squared will give me c. And if I do my calculator the right way, I get 30. So we will pause there before we dive into the details of Converse and Pythagorean Theorem.